Welcome to part 2 of our tech tutorial series, where we dive into connecting AI to avatars. Let's jump right into it. First up, we need to configure our avatar. This is where the magic begins. We'll start with the VEED AI setup. Open your dashboard and navigate to the AI section. Here, you'll find options to customize your avatar's appearance and behavior. For instance, if we want our avatar to smile when it receives positive feedback, we'll map that expression to a specific trigger in our code. Now let's move on to voice synthesis. In the AI setup, you can choose from various voice options. Now that we have our avatar configured, let's integrate AI. We'll connect to OpenRouter, which is essential for enabling real-time responses. To do this, you'll need your API key. Go to the OpenRouter dashboard, copy your key, and paste it into your project settings. Next, let's implement real-time responses. We'll set up a simple listener that triggers when a user inputs a question. Here's a quick code snippet to get you started. JavaScript const user input, sharecourse document, get element by ID to user input. User input dot add event listener, key press, function event, if event.key, sharecourse enter, const response, sharecourse await get AI response, user input.value, display response. This code listens for the enter key and fetches a response from our AI model. Now let's talk about emotion handling. For example, if the user expresses frustration, we can program the avatar to show concern. This can be done by analyzing the sentiment of the user's input and mapping it to specific expressions. Input a few different phrases and observe how the avatar reacts. You should see it change expressions based on the sentiment detected. This also creates a more human-like experience. As we wrap up this section, remember to save your configuration. Welcome back. Today we're diving right into connecting AI to avatars. Let's kick things off with a quick demo of what we're building. Here's our avatar, ready to respond in real time with expressions that match the conversation. Now let's break down how we got here. First, we need to configure our avatar. Head over to the AI setup panel. You'll adjust the facial features, clothing, and even the background to match your project's theme. Next, let's talk about expression mapping. This is where the magic happens. We'll map specific expressions to different emotional cues. For instance, when the avatar receives a happy response, it should smile. Here's a quick snippet of the code you'll need. JavaScript const expressions, happy, smile, sad, frown, surprised, wide eyes, function map expression, emotion, return expressions, emotion, neutral. Now, let's move on to voice synthesis. Here's how you set it up. JavaScript const voice settings, bars language, NUS voice, Joanna, function synthesize voice, text, const utterance, new speech synthesis utterance, text, utterance lang gabak, voice settings language, utterance.voice, speech synthesis get voices, find voice, carve voice, name, voice settings.voice, speech synthesis, speak, utterance. With our avatar configured and voice set, it's time to integrate with OpenRouter for AI responses. This is where we'll connect to an API that handles our AI interactions. Here's a simple setup for that. JavaScript const API URL, https api.openrouter.com v1 non-large respond, async function get AI response user input, const response, await fetch API URL, method post, headers, content type, application JSON, body JSON, stringify, input, user input, const data, await response, JSON, return data response. Now let's test this out. We'll set up a quick interaction loop where the avatar listens for user input, fetches a response from the AI, and then speaks it out loud. Here's how that looks. JavaScript document.get element by ID user input. Add event listener, input, async, event, oxdope, const user text, event.target.value, const AI response, await get AI response, user text, const emotion, analyze emotion, AI response. Assume this function analyzes the response const expression, map expression, emotion, avatar.set expression, synthesize voice, AI response. This loop allows for real-time responses, making the interaction feel natural. Welcome to the third part of our tech tutorial series. Today, we're diving into the exciting world of real-time features that can elevate your applications to the next level. Let's jump right in. First up, let's talk about live responses. Imagine your users interacting with your application and receiving instant feedback. To achieve this, you need to implement efficient data handling and processing techniques. Utilizing WebSockets or server-sent events can significantly enhance the responsiveness of your application. Now, let's explore dynamic avatars. They can also provide a personalized touch to your application. By integrating avatars that react in real time to user inputs, you create a more immersive experience. Consider using libraries that support real-time rendering and animation. This way, your avatars can express emotions or reactions based on user interactions, making the experience feel alive. Next, we have interactive elements. These are the building blocks of user engagement. Incorporating buttons, sliders, and other interactive components that respond immediately to user actions can keep your audience captivated. For example, when a user clicks a button, a subtle animation can confirm their action, enhancing the overall experience. Moving on to performance tips, let's discuss response optimization. It's essential to minimize the time it takes for your application to process user inputs. One effective method is to implement debouncing techniques, which can help reduce the number of requests sent to the server. This not only improves response times, but also reduces server load. Next, let's focus on avatar smoothing. When rendering dynamic avatars, it's crucial to ensure that their movements are fluid and natural. Techniques like interpolation can help smooth out transitions, making the avatars appear more lifelike. This attention to detail can significantly enhance user satisfaction. Latency reduction is another critical factor. High latency can lead to frustrating user experiences. To combat this, consider optimizing your network requests and using content delivery networks, CDNs, to decrease load times. Additionally, implementing caching strategies can help serve data faster, reducing the time users have to wait for responses. Now let's take a moment for some live testing. This is where you can see the real-time features in action. Use performance tools to monitor how your application handles user interactions. Look for speed metrics that indicate how quickly your application responds to inputs.
Welcome to the finale of our tech tutorial series, where we're launching your AI tutor. Let's dive right into the complete system. Here, you can see the dashboard displaying our success metrics, engagement rates, student progress, and feedback scores. Now, let's move on to the final setup. First, we'll conduct a system check to ensure everything is running smoothly. Next, we'll perform a performance test to confirm our AI is responsive and accurate. Finally, we'll engage in user testing, gathering insights from real students to fine-tune their experience. Now it's time for the live demo. Watch as our students interact with the AI in real time. They can ask questions, receive instant feedback, and explore various features designed to enhance their learning. This is where the magic happens, real-time tutoring that adapts to each student's needs. As we wrap up, let's celebrate our success. Our metrics show a significant increase in student engagement and satisfaction. User feedback has been overwhelmingly positive, highlighting the intuitive interface and effective learning strategies. For those eager to implement this in your own projects, remember, the full code is in the bio. Like and save this series to keep your learning journey going. Join our AI community and let's innovate together.